Welcome back again, math students. Today we're going to be talking about all the different transformations you've done. We've already reviewed all the different transformations, but we want to be able to recognize the types of transformations that are happening and to decide if we end up with similar shapes or congruent shapes. So we've already talked a little bit about congruent. So let's talk about that one first. That's this one down here on the bottom. Congruence transformations are transformations that I get when the original, the pre-image, and the new image are exactly the same size and shape. That happens when we have translations, reflections, or rotations. When we get a similarity transformation, that means that we're going to get something that is the same shape, but it's going to be a different size. That's the one that happens when we have a dilation. The only one that gives us similar shapes is dilations, getting bigger or getting smaller. So we've already talked about congruent shapes. Similar figures, you'll notice these two triangles have the same shape. They have the same markings on the angles. You can see by the color coding which sides are the corresponding sides. We've already talked about corresponding things as well, but these are clearly not the same size. So they are similar shapes. When we talk about similar shapes, we're going to use this symbol right here. When we have congruent shapes, we have the equal sign with the little squiggly thing on top. That squiggly thing is the only thing that we have for similarities. So the angles you can see right here, I've got them listed. The angles are congruent. Angle A and angle D are congruent. They've got the same markings. Angle B and angle E are the same. Those are all congruent. However, the sides are not congruent. They are, however, proportional. So we can write proportions here. So we could say that side AB, which is this side right here, over side DE. So those are the two that match. If I would make that a fraction and then make another fraction with any of the other pairs of sides, we've got the two blue ones that are listed next here. Those fractions, those ratios would be equal. And if you remember back to proportional work that you've done, you should be able to multiply the diagonals and see that those are congruent. Or you should be able to change those both into decimals and see that they're congruent. So when we are writing a similarity statement, the last thing that I want to talk about, again, this is thinking ahead to geometry. If I'm going to write a similarity statement, I have to make sure that I've got things in the correct order. So if I want to call my first triangle, triangle ABC, and I like to do that because it's alphabetical, but I would have to match up angle A, or I could just throw in a marker. I'd have to find angle A that matches up with D. That's why they're both, they're both first in my names. B matches up with E. That's why they're both second in my names. And then C and F are third in the names because they match up. If I had changed the name, if I didn't go alphabetical on this, if I would say that I have angle or triangle BAC, that would be similar to the other triangle, but I'd have to get the naming right. So B matches up with E, and then A matches up with D, and C matches up with F. So the order in those names matters. Please be very careful with that. Okay. In this one, we already have our original shape graph. That's the red one because it doesn't have the primes. And then we've got the new image, the blue one graph, and it does have primes. So that one is going to be make sure that you're aware of which one's the original, which one's the new one. I want to know what kind of transformation this is. So because it's changing size, that means that it has to be a dilation. And because they are not the same size, those triangles are similar, okay? It doesn't even ask me really to find like the scale factor or anything, but I'm hoping that you can see that with the work that they have shown right here, they doubled everything and multiplied everything by 2 to get the new image. So the scale factor was 2 on this. These two pentagons, remember pentagon just means that it's got 5 sides, 5 vertices then also, 5 angles, really that's called. I have my original pentagon, which is the red one, and then I've got the new image, which is the blue one. I want to know what's happening here and if they're congruent or not. So in this, we can be looking at the ordered pairs to find the type of transformation that happened, or I could look at this and say, oh, I see that point B in my original one was at the top, and now it's down here at the bottom. Point C was on the right side, and now it's over here on the left side. Point A was on the left side of my original one, but now it's on the right side here. I'm hoping that you can see with those arrows that I've drawn, this is a rotation. And honestly, I maybe shouldn't have drawn all my arrows going the same direction because this is a 180-degree rotation. So I don't care if we're going clockwise or counterclockwise, but it is a rotation. It's 180 degrees. And because it's a rotation, that means that they are going to be congruent. Remember, the rule for rotations is just change all the signs of your numbers. So 2, 0 would go to negative 2, 0, 3, 2 would go to negative 3, negative 2, and so on. Here we need to be careful because if you're not looking at the letters, it could look like a possible rotation kind of a situation. However, I want you to look at where A, B, C, and D are oriented in the original shape. And then in the new image, A and D are still on the bottom. Still on the bottom there. B and C, so it didn't turn at all. This is just a slide. This is a translation. And since it's a translation, those are going to be congruent. The translation notation I've got written right here, x plus 3, y plus 4. So if I would look at point D, for instance, I would move 1, 2, 3 to the right and 1, 2, 3, 4 up. That's how I get this translation notation. In this one, you can see our original image again is the red one. The blue one is the new image with the primes. And you can see that, hopefully you can see that it's reflected over this x-axis. This is a reflection over the x-axis. And because it's a reflection, they're going to be congruent. Remember the rule for reflecting over the x-axis is that the y is going to change signs. So if you look at point A, for instance, to go to A prime, we'll just change the sign on the y. Now, all of those were in your note packet, and I forgot to mention that you should be looking at your note packet every single day, but now we've got some example problems. Also in your note packet, I would like you to be completing these with me. I want to be able to identify the kind of transformation and then decide similar or congruent. Clearly, these are not congruent. These are going to be similar because it changed size. And because it changed size, that tells me that it's going to be a dilation. Right? Something else that we should be able to decide is what the scale factor is. If we're talking about a dilation, I should always be able to find the scale factor. So the scale factor here, again, you can either count a segment or you can look at ordered pairs. Segment AB is 1, 2, 3, 4, 5, 6 units long. The new one is only 2 units long. So new over original is 1/3 for my scale factor. And that also makes sense if we look at these ordered pairs. Every ordered pair, every number is being divided by 3. On this one, again, since it's already graphed for you, you should be able to recognize that this is going to be reflecting over the y-axis. And that means it's going to be congruent. Remember, when we reflect across the y-axis, the x's change signs. So this went from, for instance, a -4 to a +4. I know it's kind of blurry, but hopefully you can see that all right. When our image and pre-image overlap, I think some students get a little confused on some of these. However, you can see on this that B, for instance, was down here at the bottom, and now it's in the new image there. The C was in the bottom left corner, and now it's moved over to here. A moved from here to here. And every one of those is moving like one quadrant, 1/4 of the way around. So that means it's going to be a 90-degree counterclockwise rotation. Right? Remember, CCW can be counterclockwise. Remember, the rule for counterclockwise rotations for 90 degrees is you change the sign of the original y and then change the order. So this one changed to a -1 and I put it first. This changed to a +3 and I put it first. And for the last problem, it doesn't turn or change in size or reflect. It's all in the same orientation, I guess. So as we're looking at this, this is going to be a translation. It's just sliding. That translation notation, by the way, I don't really care if you write this part or not, saying that it's going to start with an ordered pair and it's going to change to something. Let's just take a look at the B's since they're on the top. How the X's change is I'm going to move over 1, 2, 3, 4, 5. So I would have X plus 5. And then it's going to move up 1, 2, 3. So Y plus 3. And because it's a translation, these are going to be congruent. Today's worksheet is going to have problems where you have to graph. So they won't have the graphs done for you. You graph the original points and the new points, decide what kind of transformation it is, and then tell us if it's congruent or similar. If you have any questions, let me know.